Hello everyone, myself Umi Mehta, and in operating system, let us discuss what is shortest job first scheduling algorithm. So basically this figure says all about it, that from this shortest will be chosen first. So among all processes, the shortest process will be chosen first. Okay, so let us discuss what is the selection criteria for it. So the process that requires shortest time to complete its execution is served first. Okay, so this is the basic criteria, that which process required minimum amount of execution time in CPU, that process will be selected first. Now the decision mode, so it is a non-preemptive. It means once a process is selected, it runs until it blocks for an IO or some event, or it terminates. Okay, implementation. So how we can implement it? So all processes in a queue are sorted in ascending order based on their required CPU burst. When CPU becomes free, a process from the first position in a queue is selected to run. So basically, the processes are sorted in ascending order first. Based on what? Based on its CPU requirement time. So which is called CPU burst. So this strategy can be easily implemented by using, we have seen that sorted FIFO queue. So sorted FIFO means first in first out, but it must be sorted. So let us discuss the example of shortest job first. So here it is the process P0, P1, P2, P3. Its arrival time P0 comes at 0 second, P1 comes at 1, P2 comes at 3 second, and P3 at 5 second. So we have considered all this time value in milliseconds. Now the time required for P0 is 10 millisecond, for P1 it is 6, for P2 it is 2, and for P3 it is 4. Now we have to first draw Gantt chart of shortest job first for this example. Now basically what happened here, that at the time of 0 millisecond there is no another process than P0. So if we try to arrange this process in ascending order, there is no process other than the P0. So first we have given the CPU to process P0. So in here process P0 is assigned a CPU for 10 millisecond. Now the 0 to 10 millisecond. So time is passed up to 10 millisecond. Now all three processes are arrived. It means P1, P2 and P3 are there in between 0 to 10 milliseconds. Now we have three processes, P1, P2, P3, and its CPU burst time 6, 2 and 4. Now we arrange that in ascending order. It will be like P2, then after P3, and then after P1. So now this order of execution in CPU will be like P2, P3, and then P1. So P2, it will be executed for 2 milliseconds, so 10 to 12. Then P3, it will execute 12 to 16, and then P1. So here 2, 4, and now it is 6. So 16 to 22. So this is the Gantt chart of the shortest job first. So initially only process P0 is present and it is allowed to run. But when P0 completes, all other processes are present. So we have to sort them. So the process with shortest CPU burst, P2, is selected and allowed to run till it completes. So whenever more than one process is available, such type of decision is taken. So initially we have only one process, so there is no need to arrange in an ascending order, and we do not worry about selection. But when there is more than one processes are present, we have to select one of them. So based on shortest CPU burst, we selected P2. Okay, so this procedure is repeated till all processes complete their execution. So this procedure is repeated. So these are the table that process, its arrival time, its completion time. So the time required is 10, 6 to 4. Finish time for the P2 is finish time of P0 is 10. For P1 it is 22. For P2 it is 12, and for P3 it is 16. We can say it from that Gantt chart. So here it is finish time for P0 10, for P1 it is 22, for P2 it is 12, and for P3 it is 16. Now what is turnaround time? So turnaround time is nothing but the finish time minus completion time. So for process P0, so this finish time we have taken from the Gantt chart. So if we do not prepare a proper Gantt chart, we cannot identify or calculate a exact or correct finish time. Okay, so this is the finish time. Then turnaround time is nothing but the finish time minus arrival time. So if we write wrong finish time, again our turnaround time is also wrong. So we have to very careful in drawing Gantt chart. Okay, so 10 minus 10 it is 0, then 22 minus 1 it is 21, then 12 minus 3 it is 9, and 16 minus 5 it is 11. So this is turnaround time 10, 21, 9 and 11 for process P0, P1, P2 and P3. Same waiting time is nothing but the turnaround time minus completion time. So the for process P0, 10 minus 10, for process P1 it is 21 minus 6 it is 15, for P2 it is 9 minus 2 so 7, and for P3 it is 11 minus 4 so 7. So from that we can calculate average turnaround time, which is 10 plus 21 plus 9 plus 11 divided by 4, which is equal to 51 divided by 4, 12.75 millisecond. And same it is waiting around time 0 plus 15 plus 7 plus 7 divided by 4. So 29 divided by 4, which is nothing but the 7.25 millisecond. Okay, so this is example of shortest job first. What is the advantages of this scheduling algorithm? That it is having less waiting time, it good response for short processes. But what is the disadvantage? It is difficult to estimate time required to complete execution. So this is the disadvantage that we cannot estimate time. And starvation is possible for long process. Starvation, it means that long processes may not get ever chance to execute in CPU. So long processes may wait for ever. So this is the disadvantages of shortest job first. Okay, so these are the all about what is shortest job first algorithm, what is the selection criteria, what is the decision method, how we can implement it, its example, its advantage and its disadvantage. Okay, thank you.